This summer, I went on a vacation with my family. It was a road trip, and it was all of my immediate family. My parents, me, my brothers, my sister, my son, and my niece, all packed into an SUV for a road trip down to Florida. So this is a couple of hours. We ended up having a blast. We went to a bunch of amusement parks and had a great time. There was one night where we were hungry. We had gotten done pretty late, and the only thing that was open was a fast food drive-through. So we go to the drive-through, and we were really surprised to see that the entire drive-through experience was replaced by AI, meaning the order system was completely replaced by AI. The only humans in the restaurant were the ones inside of the locked door who would cook in the food and would bring the food out to you. Now, in theory, a drive-through feels like a perfect application for AI. This is a place where we can reduce mistakes. We can reduce wait times. In an industry that's already operating on pretty low margins, we can also reduce costs as well. And then from the customer's perspective, for an introvert like me, not having to talk to somebody kind of sounded like a dream. But in reality, this was the most frustrating experience of the entire trip. This system could not understand our order. It kept timing out. It kept getting the order wrong. It couldn't understand the difference between a grilled chicken sandwich and a grilled chicken salad. It couldn't hear over the background noise. And it definitely couldn't understand the frustrated sentiment of the user that was in front of it. Now, I imagine that as this technology was being developed, the software engineers were developing it in a very controlled and quiet, sterile environment. I imagine software engineers around a Zoom meeting, no background noise, and they whisper or they speak loudly into the microphone, and they articulate a very perfect and polished order. And the order itself is very succinct and simple. They lean in, and they say, "Can I have a burger? No onions, no pickles." And the system thinks for a second, and then the order populates exactly the way that they ordered it. And it's exciting. There's probably Zoom emoji reactions and little hand claps and things like that. It is exciting to think that this could be our reality. But it's not reality, is it? It's not reality for the user. The reality for a drive-through is sirens blaring. There's car horns in the background. There's kids in the street. Reality is gusts of wind that make the microphone sound like static. Reality is frustrated parents in the front seat waiting for their children in the back to finally decide what they want to order. We had to go through this drive-through 3 separate times until finally my dad got annoyed enough that he just pulled over the car into the parking lot and banged on the door until we got to place the order with an actual human. Now, I'm sure that as I'm explaining this story, you're imagining a similar story that you have. Everybody has a story like this. There was something that you wanted to get done, something that you used to be able to get done pretty easily. But then one day, AI got involved. And what was once a paved path to your destination is now blocked by the very technology that was meant to make it better. All of these stories collectively illustrate a major problem when it comes to the way that we think about building AI. A lot of times we're not building it with a strategy in mind. And oftentimes we don't even consider the way that our users are actually using the software. Gartner predicts that over 40% of agentic AI applications will be canceled by the year 2027. Why? Because of a short-sighted approach that stems from a very pervasive myth. This myth is that AI is a magical, universal solution that can blindly be applied to any application and instantly make it better. And it's not necessarily the technology itself, it's the implementation or the lack of implementation, the lack of a strategy. It's the overemphasis on the what. Let's get a chatbot in there, and an underemphasis on the how and the why. I refer to this phenomenon, this mindset, as the hype-driven web. Anytime that we slap a chatbot onto the end of a project as just a last minute feature with no strategy, we waste resources. We degrade the user experience. The promised value never materializes. Nobody wins in this scenario. I think that there's a better way to do this. So I think that if our goal is to make things better, easier, more attractive to our users, and that should be the case, right? Because the users are the ones that are buying our stuff. They're the ones that are using our stuff.
I want to have a conversation with people, and avenues like this conference, are highly valuable to get out of your bubble, get out of your circle of influence, and just get other insights and other feedback. And you cannot have that by being online.
The best thing are the connections, and you can access to your heroes, right? Some people that you've been following for so long time, and they are here and they are available to talk to you, and they are willing to listen to you, to your ideas. I think that makes everything worth it, right?
So if our goal is to make things better and easier for them, why not start with the user? Why not start with what the user wants and then leverage the technology that will allow us to build the software that helps them to get there? Let's take customization, for example. When it comes to personalizing our site, there is only so much customization that we're able to do, right? We understand that all of our users are different. Every user is unique. Unique people have unique needs. Unique people have unique workflows. They have different things that they want to come to your site to do. As software developers, we accommodate for these differences by defining these predetermined paths for our users, and they can go down these paths in order to reach their ultimate goal. Well, we might have a nav, we'll have forms, we'll have several pages and buttons that people will go through. So you go to a page, you click the nav, you see the drop down, then you click the button, then you fill out the form, and then you press submit, and then you see the nav, and then you press the button, and you see the next page, and then you click the button, and then you see the next page, and so on and so forth. And we manage all of this using state management and conditional rendering, right? But all of this is still pretty prescriptive. And the truth is that human intent, human needs, human preferences, none of that is a simple Boolean. And the one-size-fits-most solutions that we've been confined to rarely fit everyone equally. So as a result, we end up missing opportunities to provide value for certain users, or worse, we ostracize and leave out certain groups entirely. And it's not just that. We also have a hard time getting actionable insights from our sites and from the data. I think about it like a maze with only one possible route. We know where the users can come in, and we know that there are certain defined destinations that your user can get to. We could put sensors in the maze, and we could say 80% of users slow down when they turn this corner, or 40% of users drop off at this particular step, the create account step, right? And we might assume just from that bit of information incorrectly that users are dropping off at this stage because they feel like this isn't an app that requires an account. Maybe they don't feel like they need a user profile. And so we as software developers take that information and we determine that this isn't worth our resources. Let's not work on building out this create account flow. When the reality was that the account creation process required way too many steps. Even for a standard user with no special accessibility needs, it was a pretty overwhelming process. Maybe our users instead wanted a sign-in with Google option. But we start with this very limited set of data that doesn't give us the full context of what our users are looking for. And then what do we do with that data? Well, if we have any chance of processing it effectively, an organization might have a data science team, a marketing team, a user experience team, and also have an external consulting company that they're hiring to collect benchmark data to compare with how their company is doing in contrast with the rest of the industry. But none of these teams communicate, right? They all work very much in silos. There's no collaboration. The only time they really talk is just to argue over a single static path to push the product, right? One perfect path for millions of users based on biased and pretty fragmented information. But it's not the data I really have beef with, and it's not the nav bars that I have an issue with. It's just that as things get more complex, as we start to add more variables to the fold, as we start to add more conditions, more state, more pieces of data, more options, our app starts to become more and more complex, and we start to reach these limits with how much customization we can incorporate, right? So I feel like this is a perfect opportunity to leverage AI. AI can allow us to be able to get to much more closer websites that are more closely aligned with our users' intent. Something that I've been really excited to think about lately is generative UIs. So generative UIs are where we use AI to be able to understand the intent of our users and then to be able to create a layout on the fly that mirrors our users' intent. So normally this is coupled with some type of natural language input, and your user can put in their intent in a natural means through text or through voice. And then the generative UI leverages an LLM to be able to understand and grasp the concept of that unstructured information and turn it into a relevant layout. Then as your user changes intent, the layout changes and ebbs and flows with the user's change in behavior, right? I think of it kind of like a web Sherpa, right? It's like, hey, user, here's your journey. Where do you want to go? And rather than a predetermined, predictive, prescriptive path of nav bars and buttons and forms and multiple pages, the app generates, it derives and infers your intent and then creates a page on the fly that allows you to get to that destination much more quickly. A great example of this in the real world is Google search. So Google search, as mentioned, is paired with a natural language input, right? So we have a means of communicating with this application through text or through voice. And for some Google search results, it will be a list. Like if you look up maybe who is Shaundai person, for example, you might get a list of blog posts and conference talks that I've given. But other searches generate a different layout. For example, a search for flights from Atlanta to New York, instead of a list of different airlines and random blog posts that are pretty irrelevant about trips to Atlanta and things to do in New York, Google's LLM infers that my intent is to buy a flight from Atlanta to New York. And what it does with that information is it aggregates a list of airlines and flight prices, and then allows me to select the dates and times and purchase a ticket right from within the interface. So again, taking my intent as the user and bringing me right to the destination, right? Saving me so many steps, saving so much cognitive load. Now, I used to think that the only way to build out a self-assembling UI like this was to just let go of the reins completely and let the LLM do all of the generation. Like let the LLM generate code in the runtime and then just let it go wild. Now, to me, that sounded a little bit scary. AI is still in its very early stages of maturity. And it's also, generative AI is non-deterministic, which means that if you put the same output over and over and over, if you put the same input in over and over and over, you'll have at least a slightly different output every time, if not a vastly different output. That could lead to very inconsistent and unpredictable UIs. Not to mention, if you have a faulty model, it could introduce bias, it could introduce security vulnerabilities, or just plain old mistakes. I was not prepared to assume that type of risk in a production-only application. So I did a little bit of research because I'm like, if Google can do it, I can do it too, right? I found out about this technique called restrictive UI generation. Restrictive UI generation gives us the best of both worlds. As engineers and designers, we are still in control of the layout, the functionality, and the components that are going to be rendered. But we give the LLM the power to understand, interpret, and convey that intent through a generated layout. The difference with a restrictive UI generation is that we register components with our LLM. We tell our LLM, these are the components that you are allowed to use. So we'll start out with the component library that we build out, and then we'll tell our LLM, these are the props that are necessary. These are the combination of components that you can pull from. So collect the intent, infer the intent, and then generate a UI on the fly using any combination of these components. So for your user, it helps to reduce a significant amount of cognitive load. No longer do they have to go through the nav, then the dropdown, then the button, and then the pages, and then the forms, and the whole rigmarole. It's your user is, imagine your app is inferring your user's intent on the fly. And as your user's intent changes, your app is changing dynamically with them. So it feels like this app was anticipating what the user wanted to do and white glove handing it directly to them, right? This type of layout brought to you by the letters A and I. So let's talk about how to do that. Here is our app. This is a luxury restaurant reservation booking app called Fork and Merge. So this app will take a natural language input from our users, and then using restrictive UI generation will generate a layout for the user that mirrors their intent using an LLM. So the first thing to note is that we're using a natural language input. We're allowing our user to give us text that we can send to our LLM, and our LLM will infer the user's intent from that. The power in giving your users a natural language means of communicating with your system is that natural language is such a rich source of intent information. Think back to the maze that we talked about, right? It tells us, and natural language tells us so much more than a click would, for example. We can derive way more information about what the user wants to do, the user's sentiment, and we can use that to construct a layout that much more accurately mirrors their intent. So we'll take that structured piece of text or unstructured piece of text, and then we'll send that over to our LLM to process. And our LLM gives us the power to be able to not only process that information, but spit out a React component or some structured information afterward. Let's talk about how that happens. So what is an LLM? A large language model is an AI model that falls under the broader domain of natural language processing. These models are trained on massive amounts of text and data. So after being trained on that much text and data, millions and millions of pieces of text and code, your LLM is able to derive patterns in relationships, understand relationships and patterns in human-like text. So it can not only understand it, it can also generate and output that text. For example, in the text, I like to eat, because your LLM is trained on this information, it can understand that the next word after I like to eat might be food or breakfast or pizza or tacos. But what makes a LLM so much different and so much better for our type of application is that it is equipped with this transformer architecture. The transformer architecture has an attention mechanism which oversees, kind of like a supervisor, oversees the sentence or the block of text and helps to infer the context from that text. For example, in a sentence like, what's the right way to hold chopsticks? The attention mechanism can identify the word right as meaning correct. But in the phrase right-handed chopsticks, the attention mechanism could look at that phrase and understand that right, in this case, means the opposite of left. So this is one reason why we want to reach for an LLM. Now, a traditional NLP, natural language processor, is able to interpret information from a block of unstructured text like this, but it doesn't give us the full picture. It doesn't give us the context. It can derive keywords and things like that. So we could say, great place for a big birthday dinner. Your NLP could identify birthday dinner as an event. It could identify place as a location. It might say that we could categorize this entire phrase and say that this falls under the restaurant category or the dining category or the reservation category. We could derive a sentiment and say, this is a largely positive phrase because it starts with the word great. But that's not really the type of information that we're looking for, right? It doesn't give us enough of the context of the sentence. And NLP also, human language is kind of messy. So an NLP would get tripped up if there's different words and different phrases that kind of mean the same thing. For example, if someone said a great place for a big birthday dinner, but another person said a great location for my special day or a great spot for my special day, an NLP would have trouble determining the difference. It might return results, irrelevant results for birthday dinner or things related to birthdays or things related to things that say special or locations that have the word special in the title. But again, this isn't the type of contextual information that we're looking for. Our LLM, by contrast, is able to take your user's input and derive an actual intent from it. So it might say, great place means a place with high ratings. A big birthday dinner means a place that can accommodate a large party. We might also look at more context about the user and understand what means great to this user. Maybe this user has a preference for Thai food. Maybe this user is vegan. And so we'll take this intent, we'll be able to infer this intent using our LLM, and then we'll be able to output something that's meaningful. What could that be? Pretty much anything. So an LLM is able to output not only unstructured output like text and code. We'll focus on today the structured output, and it can output JSON or React components, which is what we'll use. So our user sends their query on the client, and the client will send that query over to the LLM to be processed. So we'll have reservations for a big birthday dinner on Saturday. And now our LLM is responsible for inferring the intent. What your LLM will do from here is orchestrate a list of tasks that it needs to do in order to gather that intent data. So at this point, your LLM might need some help. We might need some more context because this input, this reservations for a big birthday dinner on Saturday is great. This is great context, and we understand a little bit about what the user wants to do, but we probably need some more information from different places, right? We might need some information from the restaurant. Let's understand if this restaurant accepts reservations. Let's find out if this restaurant accommodates a big party. And so these are things that the LLM is going to need to understand. We might need some information from local storage to find out about our user. What are our users' preferences? So by traditional means, an LLM would need some code or a system would need some code to be able to infer this, right? We might write some query requests, some fetch requests, some async requests to be able to gather that data. Or there's an easier way that we can do it, an easier way for your LLM. And this method allows your LLM to focus on just the orchestration of the tasks and getting them done in the order that they need to in order to fulfill a relevant response for your user. And this is called MCP, or Model Context Protocol. MCP is a framework that standardizes the way that your LLM can interact with different forms of data that are external or even internal to your app. So it gives your LLM the opportunity to, as mentioned, just focus on orchestrating the tasks rather than trying to figure out how to get that information, rather than writing the code to get the data from this API, or rather than writing the GraphQL queries that's going to get the data from our local storage. The MCP is like your LLM's right-hand man. It handles all of that for your LLM. So this is how it works. Your user sends the query, and then that query goes over to your LLM to process. Your LLM puts together a list of tasks that it's going to orchestrate. Let's first find a list of restaurants in the area. Next, let's filter that list of restaurants down to restaurants that only accommodate big parties. Then let's find ones that have reservations available for Saturday. Let's also find intent data for the user more context about the user, and find out what these users' preferences are, dietary restrictions, things like that. So it will generate a list, and then it brings that list over to the MCP. And the MCP is responsible for orchestrating all of the execution of that task and bringing out the data to your LLM so that it can focus on just the processing and getting your user their relevant results. So the MCP goes out and reaches out to all those APIs, the local storage, the tools, the prompts, and then it just brings back that data for your LLM. An analogy that I think of is the Yellow Pages. Hopefully I'm not dating myself. Yellow Pages were how we got phone numbers before Google existed. I think it's crazy that we're talking about AI and I existed before websites. And that's pretty nuts. But Yellow Pages, they were giant books that just used to show up on our doorstep. And it would give us access to phone numbers for everybody. This is the way that the world communicated before there was email and the web. And this is just a standardized way for us to communicate with folks. You have a list of phone numbers and you can reach out to find a plumber, you can find an electrician, you can find a cleaner, you can find a handyman or a handywoman from this list. All you have to do is just know the things that you had to do and you can go off and make the calls. MCP gives your LLM the Yellow Pages. So using your MCP, your LLM can just make call after call. Let's get reservations. Let's check the calendar conflicts. And then your MCP will return that data back to your LLM. Again, your LLM is just focused on being able to orchestrate all the tasks and return the relevant results to your user. So now our LLM has user context. It has the data that it needs, and it has your user's query. Are we ready to execute? Not yet, because we haven't given the LLM instructions on what it needs to do yet. So the LLM knows that this is the user's query, but it doesn't really know what it's supposed to do with this query yet. So traditionally, the way that we would set something up with a system like this is by, again, writing a bunch of code, managing a bunch of state, making a bunch of API requests, and using conditional rendering and state to manage all of that between pages. The beauty with the LLM, remember, is that it's trained on massive amounts of text, right? It can infer intent and it can infer meaning from text. So let's let the LLM do what it's trained to do. Let's just give it text. And that's what a prompt is. A prompt is just a text, a piece of text that gives the LLM instructions on what it is meant to do. Now, we don't have time to go into the art of prompt engineering, and it is very much an art, but there is some science to it. And the main thing to keep in mind is that a prompt should be very robust enough to give your LLM as much context as it needs. The more robust, the better. The less hallucination and the higher the quality of the results that your LLM will return for you. In our case, we just put together a quick one, letting our LLM know that it's meant to generate a UI using the predetermined components that we've provided to it. Other things that you can think about incorporating are example inputs. We can define a schema and we can say these are the props that our components will take. We can give it example output, and this is what we expect to have output, which we will, and we'll talk about that in just a second. We can give it information about the context that it has. You have access to this MCP and you will have access to a user's query, and we can go to that point. And finally, because we are using restrictive UI generation, we want to provide our LLM with the list of available UI components. We're telling our LLM, you may use any of the components in our component library. By the way, your component library will have more components than just five. You can use any combination of these 5 components, infer the user's intent, and then build a layout using any combination of these ones. And so our user can now put in their query, and the LLM is made to be able to build a layout for the user on the fly. So your user puts in their query, and then the LLM articulates the intent. And then as it builds an experience that mirrors their intent. And as the user's intent changes, the app interface changes dynamically with the user's preferences. Okay, so for the user, again, it feels like this app is anticipating what the user wants to do and just fast forwarding them right to their destination. You can imagine that the benefits become greater as you start to adopt more and more of this in nested layers among your app, as the boundaries of the generative UI get more granular. And from your user's perspective, it feels like a white glove experience. It feels like their intent is matched by the digital experience in front of them. So it's great. Now, I think that as we as software engineers start to adopt and pay more attention to LLMs and generative UI technologies and different methods of incorporating AI into the architecture of our apps, there'll be more available to improve our developer experience. There'll be more best practices around LLMs. There'll be more hardening around the MCP framework, especially around security, to make sure that it's ready for production apps. And I also imagine that there will be more frameworks and libraries that help us to get to these outcomes a lot faster with even less coding that's involved than now. Just last week, I had the amazing opportunity to learn from the framework creators themselves about a new framework called Hashbrown. And this framework allows us as front-end engineers to manage everything that we talked about from the front end, just using React hooks. We can register our tools, we can register components, we can even set up AI chat if we want to, just using React hooks and Hashbrown. So I definitely recommend checking that out. All right, so going back to our original story. If I were to be tasked with building out AI in a drive-through, if I were the one responsible for replacing the drive-through experience with AI only, with the intent-driven web in mind, how would I implement this? Well, I wouldn't do it. Okay. Hopefully and I'm kind of joking, but kind of if you learned anything about the intent-driven web today, it's that it's not so much about the technology. It's not about what's hyped up and what everybody's talking about. It's about the user first. We're taking a more user-centric view of technology, and we're leveraging the technologies, the software, the libraries, and the frameworks that allow us to get our users there much more quickly. Not everything requires a chatbot. Not everything requires an agent. There are many applications that are amazing applications for LLMs, as we've just described. But let's start with what our users are thinking. So one lesson that I took away from after reflecting on the drive-through experience is a universal, I believe, truth. If your intentions are to replace an existing workflow or existing system with a new system, you have to make sure that you're testing extensively and testing it on real world subjects. Do this testing for a long period of time. It's important that we build software that enhances our users' experience, not hinders that experience. So we want to make sure that we aren't incorporating any new software or any new workflows that end up blocking other workflows or end up ostracizing certain groups. All of our testing, all of our evals need to have human intent in mind. So as we're doing our testing of our AI, right, there's part of it that's going to be evaluating the AI performance and the performance of the model. Is our model returning the results in a fast way, But also, we need to be testing that our apps are doing the things that that our apps are enabling our users to do the things that they came to do. If not the same as they were before, able to do things a little bit more quickly, right? So we should be enhancing that user experience. Incorporate also ways for your users to give you feedback. AI shouldn't be the only means of your customer communicating with you. And this could be something as simple as a thumbs down in your LLM, in your interface, or a little link that says not what you were expecting, or some other way to create a layout that is different from what the LLM described. We talked a lot about generative UI. We talked about restrictive UI generation and LLMs and when and how to incorporate it. I think that we're at the cusp of a major shift in the way that we architect the front end. It's not going to be as much about building out these predefined paths with the nav bars and the pages and the buttons. All of that work is going to be it can be largely handled by the LLM. And your user gets to benefit from an experience that's much more customized and personalized for their own individual needs. If we're going to get to the intent-driven web of the future, we need to stop thinking of AI as a technology that is a last-ditch feature that we just slap onto an existing experience and block users out. This needs to be a tool that we embed in our infrastructure that helps our users and also helps us as developers get to our outcomes much more quickly. So go forth and build out beautiful user journeys with the intent-driven web. And think outside of the chat box. Thank you.
Now, Shaundai, questions. And let's start from this one. How do you see the balance between automation by AI and the creative role of developers evolving?
That's a really good question. So I think automation by AI is always going to remain an important part of our work as developers. It's going to be I think of it as like a way to scaffold ourselves. Like if as a front-end engineer, if I think back to the JavaScript days, which I was not a part, I joined later. I joined after React. But if we think about JavaScript and then what React changed for JavaScript, it's still underneath the hood. It's still JavaScript, but then we have an easier way to get the reactivity with React. And we just keep on building on that framework. So I think in a sense, I think of AI as kind of a framework to help us to be more productive as engineers. So automation will always be a part of it, but it gives us more freedom to be more creative. So now we can automate away a lot of the manual things that we used to have to do, even debugging manually or writing tests, like a lot of the stuff that we as engineers don't necessarily like to do too much. We can abstract that away more and more with AI, which gives us the time to think more creatively and more strategically, like what I described. Think about things from the perspective of the user, think about things in terms of innovation and how can we make things better, larger, bigger than we've ever seen before. So I do think that AI is going to be an essential tool in the toolbox to help us to just free up time and get more time to be as creative as possible.
Spot on. Thanks for sharing this thoughts. And yeah, I actually love that developers are becoming more and more creative thanks to time we have saved by AI. Now, next interesting one. How do you see AI fundamentally changing the way front-end developers interpret and implement user intent in their projects? And before that, this is also like interesting perspective that among users, there are more and more AI agents, right? So we are entering this interesting reality. But yeah, let's start from like old gold human users for answering.
Yeah. So I think the LLM is uniquely, it gives us the ability to interpret users' intent without having to manually be part of every single step along the way. So in part of my talk, I talked about how we normally have to program things with conditional rendering and state. And so if I'm thinking about a tool for multiple personas, like I have some personas who are subscribers, some who are not, some who are part of a certain demographic, some who are not, some who have certain permissions, some who have other permissions. There are so many different pieces of logic that I have to write in my head, and I have to develop these mental state management charts or like write things out into different boxes and if this then that. But in this case, all that, the LLM allows us to just kind of skip all of that stuff, like just not skip, but we can enrich certain experiences by letting the LLM handle all of the work of interpreting what that user's intent is. And the LLM gives us that unique ability because of the attention mechanism and its ability to look at the context of an entire sentence and say, okay, this is what the user means. And let's just shoot them a couple steps ahead to get them to where they need to be. So that takes a lot of work off of our plate as developers, where we don't have to do all of that manual thinking about the logic in our head. In fact, like even if one thing that you could even ask an AI agent like ChatGTP or Gemini is like, I'm trying to architect this one thing. How would I think about the different use cases, or how would I think about the different conditions and scenarios? And you can see it outlined where the LLM is like, okay, it thinks through all these different possibilities. So, but having a generative UI gives you the ability to not have to manually code all the little nitty-gritty details too.
Yeah, automation for the win. Thank you so much. And yeah, let's take the last question. And yeah, that's about let's say very general, not a VI, but very special side of how we ever work with generative AI, and it's about consistency. So to simplify, how do you achieve consistency in experience across users or across single users experience, just to make sure that it does not result in different page layout or content? Any tips and tricks on the practical side?
Yeah, that's a really good question, because even with restrictive UI generation, like we talked about, there's still the risk of hallucination. So this is where it becomes more of an art than a science. And the biggest tip that I can give you is to be as granular as you can when you're creating your tools for your MCP and your prompts for your LLM. So don't try and get a bunch of functionality. Like you should think about it the same way you think of React components. Have them be as atomic as possible. And when you're thinking about how you're going to architect a component, you're making it a component that just does one thing. Maybe it's like a view component that just handles one small visual part, or maybe it's like a hook that just handles one piece of functionality that you're going to incorporate with multiple things. Prompts in your tools the same way that you think about that. So think about the most atomic way that you can structure these prompts, and then you can kind of string them together. And that will kind of put little bumper guards all along the way for your LLM, because where I see a lot of hallucination happening is if you have like this really long detailed prompt that does multiple things, and your LLM can get tripped up at some point in the middle trying to figure out like, oh, I use the MCP, but there's a little bit more interpretation I could use in this middle part, and then I come out with the output. You want that beginning, all the pieces of the middle and the end to be controlled as much as possible. So you want to have like a prompt for that beginning part. You want to have a prompt for that middle part, a prompt for that end part. And yeah, you'll have to play with it. Also, fine tuning is an option too. It can be a little bit expensive, and it's hard to get data that is specific to your company and your exact application. And it's expensive, and it's also time consuming to do like the labeling and things like that. But you can get a long way by just having really good atomic style prompts.
100%. And what you mentioned is so close to my heart about prompt engineering. This is both art and science. Basically, this is a name of one of the sessions I often present about prompt engineering. So yeah, we are absolutely on the same page here. And yeah, I see we have one more question. It should be like super simple to answer. What is the name of framework you mentioned? Patricia is asking us.
The framework that I mentioned for generative UIs is called Hashbrown. It's at hashbrown.dev. And I've loved it. So I'm going to start making a bunch of videos about it
Wow.
if you're interested. But it was a really great.
I'm going to give it a try. Thank you so much, Shaundai, and thank you so much, dear participants. Keep your questions coming, and yeah, let's build very interesting conversations. Thank you so much, Shaundai. See you.